In this tutorial, I'm going to be showing you how to set up a table in Google Sheets, and then how to use the data in those sheets to create totals, how to turn those totals into pie charts, which then allows you to analyze your data more effectively, and then how to extract those pie charts and put them into a map, which is what we call geolocating our data. And I will explain to you why you would want to do that. So there's quite a few steps to follow. First thing you're going to need to do is open up the Google Sheet that goes with this, which is the AHGMT assignment number 3. And you will find this kind of basic layout for our data. So just in this example, imagine we have walked along a river left bank, and we have measured the total distance on the left-hand side where there were fields next to the river. And we also discovered on the left bank that there was some urban areas, housing, businesses, factories, and so on, and that there was forestry. So these are the 3 main land uses on the left bank. And we noticed on the right bank, because we had these on the left bank, we also want to include them on the right bank. So we are matching the land uses on both sides. That's quite important because it will allow us to compare at a later date. If you happen to discover more land uses that are not in these 3 basic categories, you can easily add in an additional one. Now that can either be in an other category, which is just a kind of a catch-all category that you often use to include everything else, or if it could be an actual unique category of land use that's not included above. Okay. Now, we always put our main variables in the rows. That's what we call these things here. So each of these is a row. So that's row number 11. And then the data that we want to record to match each of these rows, we put in our columns. And that's the B column there. And when we actually enter our data, we're going to be putting it into a cell, which is there. So this cell is going to include the total meters of land on the left bank that was calculated as fields. And in this exercise, obviously it's a virtual exercise, so we're not physically going out and measuring the distance on the riverbank that was fields using a trundle wheel, for example. We're going to be doing it using Google Earth. And there is another tutorial that shows you how to do that. Now, because this is the total, what we want to do, and this is what's the first sort of step of spreadsheets, is they can very quickly do data manipulation for us. So for example, let's say at 6 locations we counted fields and we measured them, and we had 20 meters worth of fields there. So that was my first measurement. We had 50 further on. That was my second measurement. My third measurement, I had a small field. Then I had a big stretch, 100. And then I had another smaller field area. And then I had a bigger field. So at 6 different locations along that river, the stretch of the river between the beginning of my study and the end of my study, which in this example is going to be 2 bridges, one in Ambank, one near the River Tay, I recorded at 6 different points the meters that were fields. Now, in between these points, I also recorded a small amount of urban. I had a small housing area, and then I had the main town, and that was it. And those are the only 2 sections where I saw urban land use. And let's just say forestry, I didn't see any forestry at all. Now let's say on the right bank, I saw a couple of stretches of fields, 50 and 50. I had a big stretch of urban, and I also then had a smaller one, and then another one further on. And then let's just say I had a big chunk of forestry at one point, and that was it. Okay. So what am I going to want to do now? Well, the first thing is I could just use a calculator to total these, and it's quite easy to see 50 equals 100. But there is a much quicker way of doing that, and that's using the sum tool over here. So I want the sum of all of these in this square here. So I hit this function button, and because I'm wanting the sum, I hit the sum. And now I have to select the cells that I want to add together. Now in this case, it's going to be C to H. Okay. And I hit enter. and it calculates it for me. Now, I could do exactly the same for these two and for this one and so on, but actually a cheats way of doing this is just to drag this all the way down, and it will copy that same equation. So if I just click on this one, you'll see this time it's the sum of C3 to H3. So there is C3 to H3. And if I go back up here, it is C2 to H2. So C2 to H2. Now, you've got to be a little bit careful because obviously here it goes from C3 to H3, and you'll notice I've got no values in these, so it's just adding nothing. But if I had, for example, down here, maybe 20, big long list of counts, I'd seen loads of small fields and I'd added them all up and put them into each cell. And I would only be totaling C7 to H7. So if this went away all the way along, let's say to N, and I had some data in N7 over here, I would just quickly change that, delete the H and change that to N. Okay. Right, that's just a little bit about summing. Now, the reason I put my sum total here and not at the end is it now allows me to quickly create my pie chart. By the way, what I'm going to do is I'm just going to delete this. And because I've got my 3 land uses and my amounts, I'm just going to select it all. I'm going to select the 2 headers as well. So the left riverbank, the total, and the fields, and then the percentage. And I'm going to now create a graph. So I go along here and I hit this little button, which is insert a chart. Now, generally with this type of data, it's going to default to 2 predictions. So it's just doing some thinking right now. Okay, and now it's created a graph, and it's a bar graph. Now, I want to use a pie chart because a pie chart's going to turn my amounts into percentages. And why do I want to do that? Well, actually, if I was just doing the left riverbank, it wouldn't really matter whether I used a bar or a pie. But because I've also got the right riverbank to consider, and I want to compare the two, if I turn the data into percentages, it's much more effective to compare. So I go over here, and the chart editor should have popped up. And if it's not, you just have to double click on the chart or click on the little dots here and select edit chart, and it'll bring up the chart editor. And I'm going to change that to a pie. Okay, and there's my pie chart. And I can see that 78.8% of my land use on my left riverbank was fields, 21.2 was urban. One thing's missing from this graph is I could actually turn this, get rid of these labels and create a key, but I'm not going to bother with that. And instead of that, I'm going to customize my graph, and I'm going to add a title. So if I hit the customize button up here and chart and axis title, and I want a chart title, and I'm going to call this the land use on the left riverbank. Okay. And I'm happy with that. That graph shows my results. So I'm just going to shrink it and move it over for the moment. Now, what I now want to do is do the same for my right riverbank. So I'm going to select my data. I'm going to go insert. And this time I'm using the other way of getting to that, which is insert and then the chart button. It's exactly the same as just touching the button over here. And this time it's going to default to a pie chart. And I just want to check that my colors match. So my blue fields match my blue here. My urban matches my urban. And I've got forestry this time on my right riverbank, which I didn't have on the other. If they don't match, you can change these colors in your customize pie slice and then change the color. The reason I want them to match is it's going to make a visual comparison much easier between the left and the right riverbank. Once again, though, you can see that we're missing one key bit of data, which is the chart title. So it's going to mirror my other one. This time it's going to be land use on the right riverbank. And hit enter, and there it appears. And I'm just going to shrink this one down. And what you can see straight away is we have got our two pie charts for the left bank and the right bank, and we can see that when we compare them, our urban percentage is much higher on the right riverbank. We have no forestry on the left, but 30% on the right. And our fields is the dominant on the left with only a quarter on the right. So that would be a descriptive comparison. But we now want to do the next step, which is lift these out and actually geolocate them on a map. So that's the next step. So what I suggest you do at this stage is just pause this little tutorial, complete this first step using the data from Google Earth, where you were shown in the previous tutorial on how to measure the distance along the river, and complete your own little table. I'll give you the basic template. When you open up the GMT assignment number 3 spreadsheet, you won't see these numbers in. You're just going to see the basic template of fields, urban, and forestry. And if you just keep it to those 3 land uses when you use Google Earth to measure, it's going to make your life a little bit more easier. If you have measured other land uses, then by all means, extend these categories and add more of your own. Okay. And in the second part of the tutorial, I'm going to show you how to geolocate this data. Okay, in this second part, I'm going to show you how to take these pie charts and drop them into a Google Doc and add them to a map that you want to display them on, which is what we call geolocating, giving your data a geographic location. So I'm going to click on my pie chart that I want to copy, and then I'm just going to go to Edit and Copy. And that's copied that to the clipboard. I'm now going to go to the location of my map. Now, you might remember creating this map and watching a tutorial on how to do this in a previous tutorial. You don't need to use this map. You could, if you wished, snip a Google Earth image of the almond and then just go to the Insert, Drawing, and then create a new one, and then paste that Google Earth image and add your map to that. And feel free to do that if that's what you want. I'm just showing you really how to add a graph to a map and why we would do that. So I'm just going to use this one from a previous tutorial just to demonstrate how you do this. So because this one has actually already been edited, I'm just going to double click on it. Normally what I'd have to do is obviously get my map and then paste it into that insert draw function. But if I just double click this, because this is a map that I've already manipulated, I can edit it. So here it is. I'm in the drawing function of Google Docs. There's the map that I want to add my pie chart to. It's just loading up. You can notice it's gray at the moment. Once it becomes live, it'll appear like that. And then I just need to paste. So I can either do that through the actions. There we go. Or I could just right click and paste. Now, at this point, because I have created a pie chart in a spreadsheet, it's asking me, do I want to link that pie chart to the spreadsheet? What that actually means is if I change that data in that spreadsheet, it will also change it in this drawing here. If I unlink it, then that pie chart will always remain the way it was as I pasted it in. Okay, so you have to, I'm going to go for unlinked, but if you're still planning on editing your pie chart, maybe at a later date in the Google Sheet, you would probably keep it as a linked to spreadsheet. And then you just paste it. Okay, so there is my left bank. There is my pie chart. I now want to bring it up and I want to geolocate it. So my left bank as I go downstream is the upper part of my map. So I'm just going to keep it from a location here. And I then want to show that this pie chart is linked to the land use over here. So there's a lot of ways you could do this. I'm just going to go with one nice little simple way, which is, kind of showing the pie chart to the area it's linked. So for example, if I wanted to show that the left bank, that my urban percentage was mainly coming from Almond Bank, I could have this arrow coming from that pie. And then if I wanted to show that the fields all linked to this, all of this stuff, then I could, for example, create an arrow pointing to them. Now, obviously, you're going to have your own data from the task that you've done. There we go. And I'm just going to go. Sorry, I should have unclicked there before selecting that. There we go. So I'm going to go from here to there. And there we are. And what you're actually doing is now these two sections of a pie chart are actually being linked to the map, to the actual locations from where the data was got, or an example of a location. And that's why we geolocate it. It brings your graph to life. You're going to see that there's a question about, why would you geolocate it? How does it allow for analysis? So if I'm looking at fields on my left bank, let's say I've also pasted my right bank and I've got a different land use distribution. I might then want to say, well, I've got a huge stretch of land use on the right bank on the environment industrial estate, which is going to alter my discharge of my river a lot, because when it rains, the water is just going to flow off the concrete surfaces. Whereas on my left bank, I've got a area of steep land, but it's got forestry, so there's going to be a bit of interception, and that would possibly lower the arrival of water at my main river channel. And I'm just extracting stuff from this Ordnance Survey map that helps explain how the land uses and how the river behaves may be connected. If I just did a pie chart, that data wouldn't be linked to anywhere. I wouldn't be able to visually see where that we have a town up at the top of our river. Then we've got very little development in the central stretch, but then we've got in the lower stretch, we've got a lot of development on one side of the river, but not on the other. Put that data on the map, I can suddenly see all of this and I can analyze it. And analyzing is to give reasons for the results you've got. And that's why geolocating is a really nice visual way of presenting graphs. Now, you don't need to use an Ordnance Survey map. You could use a Google Earth image or anything else. And what you're really doing is you're just connecting two bits of data. The first bit being the map itself, and the second bit being the data that you are presenting. Okay, and this little technique will allow you to answer any exam question, where you're asked how would you present your data. It's a really nice way to sort of say, I would use a pie chart and explain why. So that would be explaining why you're actually using this particular technique. But then I would then put this on a map, and then you then explain why you would do that. And that's linked to obviously being able to analyze your data more effectively. Okay, so I would use this tutorial to complete the tasks in this assignment and answer at the end of the assignment a couple of exam questions.